So in this video, I'm going to show you how you can write the mechanism of this reaction. This is a reaction between phenol, here you go, this is phenol, and zinc dust. Okay, so basically we all know that phenol is a weak acid. So first thing that is going to happen is that phenol, which you see here, is going to lose its proton. What's its proton? This hydrogen here, it's its proton. So it's going to lose the hydrogen to form a proton. All right, so because it's a weak acid, so definitely it can lose proton. Acids can donate their proton, they can lose it. Okay, so how would that happen? We're going to have phenol. I'm drawing that again. All right, it doesn't matter where you position the stuff. So I have hydrogen, I have the non-bonding electrons here. So how is that going to happen? What will happen is that oxygen is going to draw the bonding electrons to hydrogen to itself, like that. So when that happens, you're going to have this. You're essentially going to form what is called a phenoxide ion. Phenoxide ion is just a phenyl group with the oxygen, and you have the excess electron. You have to understand that this is coming as a result of this bond over here. All right, so now that we have the phenoxide ion, okay, the next thing is, I forgot this heat. All right, so this means that heat is needed in the reaction. So due to the action of heat, there's going to be what is called a homolytic cleavage between the oxygen and the carbon bonds of the benzene. Not really benzene anyways. The carbon here and the oxygen here, this bond over here is going to break. So now that homolytic cleavage means that the bond is going to break equally. So we're going to have half arrow and half arrow. This is as a result of temperature. All right, so when this happens, you're going to have this, right? Then we're going to have a radical here, right? Then we're going to have O2 minus. Essentially that's what this is. That's what this is, right? So, or if you like, you can write it this way, like that. All right, it's the same thing. Okay, so once we have this, as you can see, we've created a radical. So what will now happen is, remember, we still have zinc, right? This is zinc. Still have zinc. Okay, so now zinc is going to act as a reducing agent, undergoes oxidation. So zinc, which is a reducing agent, is going to undergo oxidation. Oxidation is a loss of electron kind of process, which increases the oxidation number, right? So we're going to have zinc 2 plus 2 electrons. All right, this is oxidation. Zinc is 0 oxidation state here, it is plus 2 oxidation state here. So this is oxidation, increasing oxidation state. So that makes it a reducing agent. All right, so why this is significant is because it can readily donate its electrons, all right, to, remember, in this stage, in this particular stage here, hydrogen, when this happens, all the bonding electron has been withdrawn to oxygen to give you this one, right? So we're going to have a proton generated here. Here we have plus, there's a proton generated here, We don't need a plus anyways. A proton was generated in this place, in this reaction. Alright, at this stage, a proton was generated. Okay, so once that proton was generated, now that proton that was generated when oxygen withdraw the bonding electron in the hydroxyl group of the phenol. So we're going to have zinc now. This electron, one of these electron, zinc will donate its electron to that proton. So we're going to have proton that was formed at the initial stage, this stage here. All right, now it's going to pick up the one electron from the zinc. All right, so when it picks it up, what we're essentially going to have is a hydrogen radical essentially formed. Can you see? This is how the radical is formed. The proton from the phenol as a result of electron pull from the oxygen hydrogen bond, right? You can see here, right? So, and then we are having that. All right, so let's go. Now that we've generated a hydrogen radical, now still remember we have a phenyl radical here, this phenyl radical. So the reaction will now take place between phenyl radical. We'll now have phenyl radical reacting with the hydrogen radical. So what does that mean? Phenyl radical, this is it, right, reacting with the hydrogen radical that has been generated, right? So they're going to react. Then we have the product, which is benzene. All right, so we're going to have this. This is going to be the product. And how is it the product anyways? You shouldn't forget that at these ages are all hydrogens, right? Can you see hydrogen? And this was the last one that was added as a result of this radical. So you see, we have benzene as one of the products. Now the second product, let's look at the zinc. What do we have left? Remember, we've not treated zinc. Look at zinc here. All right, what happened is that the zinc is going to be picked up by the oxide ion. What is the oxide ion? This one. Remember, this was formed when the carbon oxygen bond broke homolytically. When this bond was broken, we formed this. So essentially, zinc is going to be picked up by this one. So we're going to have over here zinc 2 plus O2 minus the oxide ion to give you zinc oxide. So you see, we have two products. This is one, and this is two. That gives us these two products over here. You see, this is essentially what this reaction mechanism looks like. So watch out for next one.